Welcome back. This is Innk, and in today's problem, we're finding the appropriate value for R2 such that the current through the square law device is set to 0.5 milliamperes. If that's the current, we know that that will be IS. So IS is equal to 0.5. Vn is 10 volts. We're given the constant A, the threshold voltage, and we're given R1, so we're finding R2. Vs has to be greater than or equal to VTR for current to flow. The square law current equation is equal to as follows. We then can find Vs, because to find the value R2, we can do a Thevenin circuit, then solve for R2, but in order to do that, we would want to know the voltage across the square law device. So the first thing we should do is take the voltage R2, which is going to be Thevenin, and in this case, let's take the square law device voltage first because we have all the necessary parameters. So that's IS over A 2.5 plus VTR. Plug in the necessary information. We get a voltage of 3.5 volts. Now, to find R2, we can then solve for the Thevenin equivalent for the circuit and then solve for R2. So we know that R Thevenin is as follow. R1 parallel with R2, that is equal to R1 times R2 or R1 plus R2. We know that V Thevenin is equal to the input voltage times the resistor that we're targeting, which is R2, which is the resistor we need the voltage across, and that is R1 plus R2 V Thevenin. Now we have a series circuit. And this is as follow: R Thevenin and V Thevenin and the square law voltage. To find R2, we apply KVL. We then have that V Thevenin is equal to the voltage across R Thevenin plus Vs. We know that V Thevenin is equal to Vin, R2, R1 plus R2, and the Thevenin resistance is R1 times R2 all over R1 plus R2 plus Vs. Cancel out, we're left with Vin, R2 equals Is, R1, R2 plus Vs. Now we can distribute, so VSR1 plus VSR2. Factor and move over and divide. We get R2 is equal to R1 Vs, and that's all over Vin minus Vs minus Is R1. We have R1, we know Is, we know Vs, and we know Vin. Plug in the necessary information. R2 will then equal to 23.3 kiloohms. And that is the value necessary, or that's the appropriate value of R2 such that the current through the square law device is set to 0.5 milliamperes. And that's it. See you in the next problem. Bye.